Some tricky questions dealing with rhombus are if the diagonals of a rhombus measure 10 and 24, find the side length. And this is a really tricky question. Try to draw a picture and label it, and then unpause this. So I don't know what to name this rhombus. It doesn't really matter. But it says the diagonals measure 10 and 24. Well, one of these diagonals actually looks longer than the other. So that one I'm going to make sure I label 24. But I'm not going to label it 24 on my picture just yet. I know the whole thing is 24, but I also know that this part and this part are equal. So they have to be equal pieces of 24. Maybe 12 and 12. This whole other diagonal is 10, but they are equal pieces of 10. What two pieces could they be to sum to get 10? And they have to be equal pieces. I think they should be 5 for each one of those. And keep in mind, it's a right triangle because it's got a right angle in it. You're trying to find what's the length of a side on the outside. But take a look at this drawing. You're actually drawing, or your actual problem is a right triangle with sides 5, legs 5 and 12, and you're trying to find the hypotenuse. So it's actually a Pythagorean theorem problem kind of stuck into a rhombus problem. The side measure must be 13. So some tricky stuff, but actually, the Pythagorean theorem was used to solve that one. Let's try 2 more. Okay, in rhombus ABCD, the measure of angle BCA is 3x minus 2, and measure of angle ACD is 12 plus x. Find both angles. So take a minute, sketch a picture, label it, and see if you can do it. I'm going to sketch a rhombus as best as I can. A, B, C, D. BCA has to be like here. ACD is this one right here. No matter how you draw your figure, these should be right next to each other, making up angle C. And keep in mind, when the diagonals are drawn in, that angle is cut into 2 equal pieces. So whatever the one angle is, the other one has to be the same amount. And to try to solve it, move over an X. I'm getting X equals 7. But I don't think I actually answered the question. Measure of angle BCA, 3x minus 2, maybe 19 degrees, and the measure of angle ACD, 12 plus x, 19 degrees as well. And another question dealing with rhombus. Rhombus, I think, has the most tricky type of questioning because that 90-degree angle in the middle and just about the diagonals, cutting the angles in half. If the sides of a rhombus are 10 feet long, how long can the diagonal be? So pause this and see if you can set it up. So I'm making a rhombus and I'm putting all the sides as 10. How long can the diagonal be? Many times people will say, well, are we talking about the short diagonal? Or are we talking about the long diagonal? We're talking about either diagonal. So when I look at this one, I might think of the small diagonal. Doesn't matter. You've got the numbers 10 and 10, and you've got a triangle. Okay, how long can that diagonal be? Now remember, this is that type of problems that we were doing on the first or second day of school, where we were listing numbers like 10 and 10 and saying, could the number be 1? And you had to add the two smaller numbers to connect to make sure that there was going to be an angle there that was bigger than the largest angle or the largest side of the triangle initially. So we would say, okay, what's 1 plus 10? It's 11. Is it bigger than 10? Yes, it could be a triangle. Could it be a half? 10, 10. Could it be a half of a foot, which is like 6 inches, and then 10 feet and 10 feet? Sure, because when you add 10 and a half, or 10 and a half, you get 10 and a half. And is it bigger than 10 feet? Yes. Remember, we did this example, I think, with markers, with the whiteboard markers. They just can't be equal because then they won't actually make a triangle. They have to add up to, the two smaller sides have to add up to be bigger, even if it's just a hint bigger than the third side, in order to make a triangle. So technically, I could even go smaller than that. I just have to make sure that I'm larger than 0. Can't be 0 for many reasons. You can't have a diagonal of 0. In addition, I want numbers that I could have decimals here. I've got a half works. A fourth is going to work because it's going to be 10 and a fourth. An eighth will work. I could keep going. It's just got to be bigger than 0. It's got to be a decimal or greater. And then I got to figure out where to stop. So you want to think about it. Can it be 2, 10, and 10? These two add up to 12. Is it bigger than 10? Yes. Could it be 3, 10, 10? 13 is bigger than 10. All looks good. So it's got to be larger than 0. We got to figure out where we got to cap this. Let's see. How about 10, 10, 10? Can you have 3 sides of a triangle be the same? What type of triangle has 3 sides the same? Equilateral. So, of course, this should be able to work. A lot of people want to stop here, but you don't really have to. And you shouldn't. Could this one be bigger? And that's the trickiest part. 11, 10, and 10. What are the 2 smaller sides? They're not the first 2 anymore. They're the second 2. 10 and 10 make 20. Is 20 bigger than 11? Yes. Could it be 11, 10, and 10? Well, these are still making 20, and it's still bigger than 12. So let's skip to like 18, 10, 10. These two still add to 20, and that's got to be bigger than 18. And it is 19, 10, and 10. 10 and 10 add to 20. It's bigger than 19. How about 20, 10, and 10? These two add up to be the same as the third side. So if you remember, we had the markers line up. And when the markers lined up on the two smaller sides, and they were the exact same as the bottom side, it actually laid flat and they looked parallel. So this cannot work. So we want to say larger than 0, but less than 20 is our final answer. Let's try some practice problems.